Welcome to our math review for Biostatistics. This quick review will refresh the core math skills you'll need for this course. The goal isn't to make you math experts. It's to give you confidence working with numbers, graphs, and basic statistics. We'll cover 6 key areas. If any of these feel rusty, that's perfectly normal. By the end of this review, you'll feel more ready to tackle the math in biostatistics. First, let's review the order of operations. When you see a math expression with multiple steps, there's a specific order we follow, known as PEMDAS. This stands for parentheses, exponents, multiplication and division, then addition and subtraction, moving left to right as needed. A common mistake is to go straight left to right without following this order, which gives wrong results. For example, 7 plus 3 times 2 is 13, not 20, because multiplication happens before addition. Think of the mnemonic, "Please excuse my dear Aunt Sally," to help you remember. Let's walk through a few examples together. Here's our first example. The expression is 5 plus 2 times 6. Let's apply our order of operations. According to PEMDAS, we do multiplication before addition. So first, 2 times 6 is equal to 12. Now the expression becomes 5 plus 12. Finally, 5 plus 12 is equal to 17. The correct answer is 17. Notice, if you had done the addition first, you would have gotten the wrong answer. Now let's see what happens when we add parentheses. The expression is 5 plus 2 times 6. PEMDAS tells us to do parentheses first. So 5 plus 2 is equal to 7. Now the expression becomes 7 times 6. And 7 times 6 is equal to 42. This gives a completely different answer than our first example. That's why parentheses are powerful. Next, let's add exponents to the mix. We have 4 plus 3 squared times 2. First, we handle the exponent. 3 squared equals 9. Now the expression is 4 plus 9 by 2. Next, multiplication. 9 times 2 is equal to 18. Finally, 4 plus 18 is equal to 22. So the answer is 22. Again, doing exponents first made a difference in the result. Now a multi-step example with both parentheses and division. First, we solve the parentheses. 8 plus 2 is equal to 10 and 3 plus 2 is equal to 5. Now the expression is 10 divided by 5 by 4. Division and multiplication are at the same level, so we work left to right. 10 divided by 5 is equal to 2. Now we have 2 times 4 is equal to 8. So the answer is 8. Notice we solved parentheses first, then worked left to right for division and multiplication. Finally, a full example with all operations. Let's take it step by step. First, parentheses and exponents. 3 squared equals 9. Then, 2 times 9 is equal to 18. Now the expression is 20 to 6 divided by 3 plus 18. Next, division. 6 divided by 3 is equal to 2. Now we have 20 to 2 plus 18. Addition and subtraction happen left to right. 20 minus 2 is equal to 18. Finally, 18 plus 18 is equal to 36. So the correct answer is 36. Notice how following PEMDAS made this manageable. Just one step at a time. Asterisk. Next, fractions, decimals, and percentages. These are different ways to represent parts of a whole. You'll see all of these used in research papers, graphs, and statistics. A fraction like 1/4 is the same as the decimal 0.25 or the percentage 25%. You should feel comfortable converting between them. If I give you a fraction, divide the numerator by the denominator to get the decimal. Multiply a decimal by 100 to get a percentage, and divide by 100 to go the other way. For example, 0.73 is 73%. Practice moving back and forth will make this automatic. Now mean, median, and mode. You'll calculate these often in this course. Mean is the average, add up all the numbers, divide by how many there are. Median is the middle value when the data are ordered. If there's an even number of values, average the two in the middle. Mode is the most frequent value. You can have more than one mode or none at all. For example, in the dataset 5, 2, 7, 5, 10, the mean is 5.8. The median after ordering the data is 5. The mode is also 5, since it appears twice. Each of these measures tells us something slightly different about the data, and together they give us a fuller picture. Graphs help us understand data quickly. You'll see bar charts, pie charts, and histograms frequently. Bar charts compare values across categories, like number of students per major. Bars are separated because categories are distinct. Pie charts show parts of a whole. Slices represent percentages adding to 100%. These are best when there are a few clear categories. Histograms show how numerical data are distributed across intervals. For example, test scores or heights. Bars touch each other because the data is continuous. A key tip: always read the axis labels and the scale before interpreting a graph. Ratios and proportions are very common in biostatistics. A ratio compares two quantities, like 3 cats for every 2 dogs. A proportion compares a part to a whole. For example, if 2 out of 5 patients improved, the proportion is 2/5 or 40%. You'll often solve proportion problems. If 2 out of 5 patients improved, how many out of 20 would we expect? Set up the equation 2/5 equals x/20 and solve by cross-multiplying. Ratios and proportions are used in risk analysis, population studies, and more, so this is a very useful skill to master. Finally, exponents and scientific notation. An exponent means repeated multiplication. For example, 2 to the 3rd power means 2 times 2 times 2 is equal to 8. Scientific notation lets us write very large or very small numbers clearly. For example, 4.5 million is 4.5 times 10 to the 6th power. To convert a large number to scientific notation, move the decimal so the number is between 1 and 10, and count how many places you moved it. That becomes the exponent. Small numbers use negative exponents. For example, 0.0000216 is equal to 2.16 times 10 to the power of -5. You'll see scientific notation used for very large datasets, tiny probabilities, and more. To recap, today we reviewed 6 key math skills you'll use in biostatistics: order of operations, fractions, decimals, percentages, mean, median, mode, reading graphs, ratios and proportions, exponents, and scientific notation. Remember, confidence grows with practice. If any of these topics felt unfamiliar, that's okay. Revisit this review as needed, and don't hesitate to ask questions. You are building a solid foundation to succeed in this course. Great work today! Asterisk.